In today's video, we're going to be talking about number sets and Pythagorean theorem. So before we talk about any of these topics, I want to kind of review over the concept of square root. The square root is the opposite operation, the inverse operation of squaring a number. So if I were to do 3 squared and you get 9, the square root of 9 is going to equal 3. Now, you'll get different types of numbers when you take the square root of a specific number. Sometimes you might get a perfect square. For example, 25. 25 is a perfect square because when I square root it, I get 5. But let's try 24. If I take 24 and square root it, you get this long decimal that never repeats, so it is an irrational number. So that is not a perfect square. So all the numbers that come out to a nice decimal, nice whole number answer are perfect squares. So 1, 4, 9, 16, 25, 36, 49. Whenever you put them in a calculator, you get a nice whole number answers. The numbers in between are irrational numbers. Now, there's ways you can simplify square roots. For example, if I had the square root of the square root of 27. I have to create a factor tree to break down 27. So 27 breaks down to 9 and 3. And I can't go any further with a 3, so I put a little dot there, and 9 breaks down to 3 and 3. Put dots at the end of those. Now to simplify it, you take out the pair. So there's a pair of 3s, so that goes on the outside of your radical. And then inside the radical is what's left over. So this 3 is left over, so that stays inside the radical. And we could double check. 27 square root is about 5.2. And 3 times the square root of 3 is 5.2. So that's a way we can check our answer. All right, let's look at another example. Maybe square root of 48. 48 breaks down to 6 times 8. It could be other numbers, but I'm going to use 6 times 8. 6 breaks down to 3 and 2. 8 breaks down to 4 and 2. 4 breaks down to 2 and 2. There are the ends of my branches. So again, I'm going to pull out the pairs of my factor tree. So we have 2, which goes on the outside, and we have another pair of 2, which also goes on the outside, and we have a 3 left over, so that goes on the inside. 2 times 2 is 4. Radical 3 stays the same. So that is your simplified version of the square root of 48. Now, say you have a number on the outside. For example, 3 times the square root of 50. Still going to break 50 down to 25 and 2, and then 5 and 5. I'm going to pull out the pair. So, but that also goes on the outside with the 3. So it's 3 times 5, and then whatever's not taken off stays inside the radical. Radical 2, and we get 15 radical 2 is my simplified square root. All right, so making sure when we simplify these radicals that we use our factor trees and get all the way to the end before we take out the pairs. Okay. Also, we talked about this unit, Pythagorean Theorem. So Pythagorean Theorem works for any right triangle. A right triangle is a triangle with a little right angle in it. Okay. A and B are called the legs. Those are the sides that make up the right triangle. C is called the hypotenuse. So a squared, the lengths of a squared plus b squared is always going to equal the hypotenuse squared, c squared. So those are the legs. This is the hypotenuse. So if we know two sides of the right triangle, we should be able to figure out the third by plugging into our formula. So here's an example of a right triangle. All right, and I'm going to label this x, and I'm going to label this 5. I'm going to label this, let's label this the square root of 3. And I'm going to label this, and I don't know what this is, so I'm going to call it question mark. You can call it x, you can call it, we'll figure out what the side is first. This is the hypotenuse because it's across the right triangle. So when I want to plug it into my a squared plus b squared equals c squared, I'm trying to figure out what my c value is. That's what I'm trying to figure out. So I plug in square root of 3, I plug in 5. So I get 5 squared plus the square root of 3 squared equals c squared. 5 squared is 25. Square root of 3 squared is just 3. 25 plus 3 is 28. Now I still have to get rid of the square, so in order to get rid of the square, I have to square root both sides. So my answer is the square root of 28. Now, depending on the directions, they might ask you to round that, or not round it, round it to get a decimal, because see, it's not a perfect square. So they might say, okay, round it to the nearest 10th, round it to the nearest 100th. If I was rounding it to the nearest 10th, it would be 5.3. Or they could say, write it as a simplified radical. In that case, you would do the radical tree. Square root of 28 breaks down to 4 and 7. 4 breaks down to 2 and 2. Take out the pair 2's. That stays on the outside. 7 stays on the inside. And that's my simplified radical, 2 radical 7. And when I double check in the calculator, 2 times the square root of 7, you get 5.3. So that is what you do when you're trying to find the hypotenuse. Okay? Now, sometimes they might have you try to find the leg. Here's my right triangle. I'm going to label my hypotenuse 5. Leg, I don't know. And the other one, we're going to label it 2 radical 3. So again, my a squared plus b squared equals c squared. Plug in 5 in for c, 2 radical 3. It doesn't matter whether you plug it in for a or b. I usually do b. So we have a squared plus 2 radical 3. That entire thing has to be squared, so I have to put the parentheses around that, equals 5 squared. Now you got to be careful when you square root 2 radical 3 squared. You have to square both the 2 and the square root of 3. So the 2 squared is 4. Square root of 3 squared is 3. So 2 square root of 3 squared is actually 12. 5 squared is 25. Bring down the a squared. Minus 12 from both sides. And you get a squared is 13. Find the square root. Both sides. So a is going to be about, let's see, 13 square root is 3.6. And you could try to simplify radical 13, but 13 is prime, right? It only goes into 13 and 1. It doesn't have any pairs, so you can't really simplify it. So square root of 13 is actually the simplest square root possible for those types of problems. All right, so that's it for number sets. Remember, when we're simplifying square roots, you use your factor tree. When you are, and then using your Pythagorean theorem, be careful when you're squaring numbers, especially with numbers on the outside. And then also make sure you can double check your work in the calculator to see if you have to round your answer or put it in simplified radical form. All right, so that's it for today's video. If you have questions in class, please let me know. Thank you for watching.